Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay. So here now today we will discuss like what is the function of this ECG machine and probably the diagram, block diagram of ECG machine. So before going to this, this was the uh, concluding section in PQRST curve, which was developed for the electrical activity that is developed in the heart. So this PR interval, nothing but beginning of the P wave to the beginning of the QRS complex. And ST segment is the connecting part between the QRS complex and the T wave. And QT interval is the beginning of the, I mean, from the beginning of the QRS complex and to the end of the T wave. Okay. Now you can see how the SA node uh, generates the pulse to activate the heart function. Okay.
The cardiac conduction system consists of the following
If the video and audio is not visible, please inform me in the chat box.
components. The sinoatrial node, or SA node, located in the right atrium near the entrance of the superior vena cava. This is the natural pacemaker of the heart. It initiates all heartbeat and determines heart rate. Electrical impulses from the SA node spread throughout both atria and stimulate them to contract. The atrioventricular node, or AV node, located on the other side of the right atrium near the AV valve. The AV node serves as electrical gateway to the ventricles. It delays the passage of electrical impulses to the ventricles. This delay is to ensure that the atria have ejected all the blood into the ventricles before the ventricles contract. The AV node receives signals from the SA node and passes them onto the atrioventricular bundle, AV bundle or bundle of His. This bundle is then divided into right and left bundle branches, which conduct the impulses toward the apex of the heart. The signals are then passed onto Purkinje fibers, turning upward and spreading throughout the ventricular myocardium. Electrical activities of the heart can be recorded in the form of electrocardiogram, ECG, or EKG. An ECG is a composite recording of all the action potentials produced by the nodes and the cells of the myocardium. Each wave or segment of the ECG corresponds to a certain event of the cardiac electrical cycle. When the atria are full of blood, the SA node fires, electrical signals spread throughout the atria and cause them to depolarize. This is represented by the P wave on the ECG. Atrial contraction or atrial systole starts about 100 milliseconds after the P wave begins. The PQ segment represents the time the signals travel from the SA node to the AV node. The QRS complex marks the firing of the AV node and represents ventricular depolarization. Q wave corresponds to depolarization of the interventricular septum. R wave is produced by depolarization of the main mass of the ventricles. S wave represents the last phase of ventricular depolarization at the base of the heart. Atrial repolarization also occurs during this time, but the signal is obscured by the large QRS complex. The ST segment reflects the plateau in the myocardial action potential. This is when the ventricles contract and pump blood. The T wave represents ventricular repolarization immediately before ventricular relaxation or ventricular diastole. The cycle repeats itself every heartbeat.
So, what is the, some people are in the waiting room, Roshni and Gautam. Okay. So, is it clear how this action potential generates in the heart, and so on? It generates the electrocardiogram, whichever in the heart function. Okay, is it clear now? Okay, so we will forward it. Uh, though this ECG, firstly, if you have seen any kind of video of ECG or EKG, you can remember this. Some wires and some connections were made in the skin of the human body, and also a machine is connected in the either end of the wires. So this wire is nothing but the connecting wires. So these connecting wires takes the action potentials from the human body and shows into the machine, ECG machine. So this, as it was told that these action potentials from the human body should be taken by the use of some electrodes, bioelectrodes. So these electrodes of ECG, these are some specifications of and some procedures of ECG, taking ECG, recording ECG. These gold standards for diagnosis for cardiac arrhythmias. It helps, this ECG helps detect electrolyte disturbances. Likewise, we have discussed in earlier stages, I mean just yesterday, that there are some calcium and potassium concentration inside and outside of the heart cell. So this is hyper, it is called, if this calcium potassium percentage varies or disturbs, then these two diseases occurs, this hyper and hypokalemia. And this ECG allows for detection of conduction of abnormalities. It was also seen that if some abnormalities is there, some abnormalities in the heart function, then it will reflect on the PQRST curve. Why? Because this PQRST denotes the proper functioning of the heart. So there should be some PQ interval, QR interval, RS interval, ST interval. So there are some fixed, I mean, some standard time gaps, like 10 milliseconds, 100 milliseconds, like this. Because from where it came? It came from a healthy body. That means doctors or the researchers taking 100 examples or 1,000 examples of a healthy human body, and they took the ECG from them and they have normalized it to this standard value, to get this standard value. And this screening, this ECG is the screening tool for ischemic heart disease during the stress test. Stress test, it is typically done on the sports persons when they are about to appear for a match, for any kind of sport competition. Before, prior to going to this participation, they need to undergo this ECG test, because they have to certify that they are physically fit, their heart functions are absolutely normal. And this ECG is helpful with the non-cardiac diseases like pulmonary embolism or hypothermia. That means pulmonary embolism and hypothermia is related to some blood activities. This, I mean, blood is generated, I mean, blood is pumped from the heart through the heart. So this ECG denotes this kind of disturbances in case of heart dysfunctions. But this is very important, that ECG is a solely a diagnostic tool. It is not a treatment. It is not a solution to get back the abnormal patient to the normal condition. It can be only seen that, or only notified, or it is diagnosed that a particular human body is, or particular human body heart is not functioning properly. It is only diagnostic tool. It is not a curative tool. Okay. Now, this electrocardiography timeline, this is a brief history. You need not to memorize it because it is a just we need to discuss only some few points to understand better that from 1872 to 1895. These are the timelines. From 1895, William Einthoven, when he introduced the ECG, proper ECG setup, and he also researched this 5 deflection of the heart function in the ECG. So they are named as PQRN, PQRS and T. So here in 1924, he got the Nobel Prize, William Einthoven, and according to his name, by his name, this PQRST, whenever these assumptions are taken, is called the Einthoven triangle. So he formed the Einthoven triangle. And what is this? Let us go to the, this is the Einthoven triangle. You can see in the previous slide, there are 3 electrodes are placed. One in the right arm, this is denoted as R. This is left arm, that is L, and right foot, left foot, that is denoted as F. Okay. Now here we are there. So this before going to this Einthoven triangle, we will see that there are 12 conventional leads. Okay, physiologically divided into 2 groups. These are bipolar leads and unipolar leads. Okay, so in bipolar leads there are 3 standard limb leads. That means these leads denotes the electrodes. Okay, leads means जो तुम लोग इंजेक्शन कभी लिए हो तो उसके उसके जो सुई रहता है, that is called the leads. Okay. Here these leads are nothing but, ये कोई स्किन के अंदर इन्वेसिव टेक्निक नहीं है. This is a non-invasive technique. It will place the electrode just on the skin. Okay. So this unipolar leads, these are 3 augmented limb leads and 6 precordial chest leads. These bipolar leads are placed on the left arm. Lead 2 is placed on left foot, right arm. Lead 3 is left foot, left arm. Okay. The lead axis forms the side of the equilateral triangle with the heart at the center. Okay. So this equilateral triangle, as the name implies, that from the heart, the right arm, left arm, and the left leg, these distances, the limb lead distances are same. Okay, so it will form this kind of triangle where this is the heart. Sorry, this is the heart, the position of the heart, and this is what? This is the left arm. Okay, this is the right arm, and this is the left leg. Okay, so we will get back to this. The sum of the potential in the 3 leads equals to 0, and mathematically it could be demonstrated that the potential in left lead 2 equals sum of the potentials in lead 1 and lead 3. This was the Einthoven's law, for which William Einthoven won the Nobel Prize. The sum total, that means this lead 1, whatever the voltage is coming, and lead 3, whatever the voltage is coming, the sum of these 2 is equals to the lead 2, the potential. Now this unipolar, there are some specifications of a unipolar limb lead. These unipolar limb leads were constituted by different electrode, which forms the negative electrodes, and the exploring electrode, which forms the positive electrode. Okay, this is the positive electrode. Now this indifferent electrode is constituted by connecting all limb lead electrodes together through an electrical resistance, thereby maintaining the zero potential. We will see how to calculate the ECG, how we will get the ECG. The positive electrode records the true potential at a given point. Here the record is the low voltage. Goldberger augmented these leads for the proper recording. Goldberger was a scientist, and he reinvented, some restructure was done, and for proper recording, and came to be known as the augmented unipolar limb leads, represented as AVR, AVF, and AVL. That means this R means right arm, this F means left foot, F for foot, and this L means left arm. Okay, this AV, that is the augmented voltage. A for augmented, V for voltage, R for right arm, F for left foot, and L for left arm. Okay. Now you can see this is the human body heart, as it was told that these limb leads, whenever it is connected with the human body, then it forms an unilateral triangle. Okay, that means the angle of this triangle, each angle is 60 degree. Is it clear? Now,
Yes.
this, you can see, this is the heart position, and from this heart position, this L, R, and F, these are equidistant. Now these are the notations that V1 means the potential of the lead 1. This is the voltage of lead 1, and similarly V2 is the voltage of or potential of lead 2, and V3 is the potential of lead 3. So lead 1, lead 2, and lead 3. Now these are some quantities. Now how they are calculated? So before calculating, this is the potential of left arm. That means at this point, this is not the potential of the lead. This is the potential of the left arm. This is the potential of right arm, and phi F is the potential of left leg. So clearly, as it was discussed in just the earlier slide, that lead 1, that is V1, that is the difference between the left arm and the right arm. Okay, you can see this expression: left arm, the potential of the left arm, and this is the potential of right arm. The difference between these two is the voltage of lead 1. Clear? Similarly, this V2, that is the voltage of lead 2, is nothing but the difference of the potentials at the left foot and the right arm. Similarly, the voltage or potential of the lead 3 is the difference of potential between the left foot and the left arm. So is it clear now? Do you have any questions? You may ask.
Hello.
Yes.
Hello.
Yes. I can hear you.
गुड मॉर्निंग सर. सर
हाँ,
यहाँ
good
पे
morning.
इलेक्ट्रोकार्डियोग्राम और इलेक्ट्रोकार्डियोग्राफी दोनों में क्या अंतर है सर?
Very good question. This, you know the term photography?
यस सर.
Okay. So photography का मतलब क्या है? Photography मतलब जो कि तुम जो फोटो खींच रहे हो विद कैमरा और मोबाइल व्हाटएवर, जो फोटो खींच रहे हो, दिस प्रोसेस इज कॉल्ड फोटोग्राफी. ओके,
ओके सर।
और जो तुम्हारे पास अगर कुछ फोटो आ रहा है तो हम लोग बोलते हैं कि पिक्चर फोटो ऐसे बोलते हैं, लेकिन पूरा नाम क्या है उसका? फोटोग्राफ, राइट? सिमिलरली द प्रोसेस ऑफ electrocardiograph, I mean the process of taking the record of the action potentials and resting potentials of the heart is called the electrocardiography. And
ओके।
the result we are finding out, the plots or the PQRST curve, whichever plotted in a paper, it is recorded, then it is called the electrocardiogram, okay, or
ओके सर।
electrocardiograph. Just like the
क्लियर
photograph and photography, it is called electrocardiograph and electrocardiography, okay.
क्लियर सर। क्लियर सर।
Okay, okay.
थैंक यू।
So, Shruti,
Hello, sir.
yeah, I'm coming to you. Shruti asked that can you share this PDF? I'll share it because
Yes, sir.
after the class it is available in the Google Classroom. Okay, and I'll share
Yes, sir.
the
Thank you.
videos also.
Yes, sir.
Okay, thank you. And whoever is asking,
सर इसमें सिर्फ सर लेफ्ट लेग का ही यूज क्यों किया सर, राइट का क्यों नहीं किया?
Acha. This was the convention. This came after the repeated times research of William Eindhoven, that from the I mean to form the unilateral triangle. देखो unilateral triangle लेने से क्या easy क्या होता है? ये जो लेफ्ट आर्म से लेफ्ट फुट का डिस्टेंस है, लेफ्ट फुट से राइट आर्म का डिस्टेंस है, और राइट आर्म से लेफ्ट आर्म का जो डिस्टेंस है, दीज थ्री विल बी सेम। तो इसमें से क्या एडवांटेज क्या मिलता है? बिकॉज देखो कोई भी कंडक्टर अगर इसका लेंथ के ऊपर रेजिस्टेंस डिपेंड करता है, यू नो इट, ठीक है? तो अभी ये लेंथ अगर बढ़ जाता है या घट जाता है तो रेजिस्टेंस चेंज होगा उस पर्टिकुलर कंडक्टिंग वेयर का। तो इसीलिए ये जो सेटअप बनाया गया इसमें रेजिस्टेंस कांस्टेंट किया गया। कांस्टेंट मतलब ये जो कंडक्टिंग मटेरियल है, ये जो लीड जो बन रहा है, ठीक है, ये लीड में जो मटेरियल यूज हुआ है दैट इज कांस्टेंट, द लेंथ इज कांस्टेंट, द cross sectional area is constant, so the resistance will be constant. Rho L by A, this formula, rho is constant,
Yes.
L is constant, A is constant. So by doing repeated research it was seen that these three positions are the perfect positions. क्योंकि हम लोग आज ही जो डिस्कस कर रहे थे इसके पहले कि 12 leads, 12 number of leads is required for taking the ECG, but most optimum, क्योंकि ज्यादा हम लोग लेंगे, जैसे कि सोचो तुम लोग अभी यहाँ पे 30 पार्टिसिपेंट हो, अभी मान लो कि यहाँ पे इसको 4 गुना किया गया, 120 पार्टिसिपेंट है, तो ऑब्वियसली 120 पार्टिसिपेंट में ज्यादा क्वेश्चन होगा, 120 पार्टिसिपेंट में ज्यादा बातें होगी, तो इसीलिए ज्यादा लीड्स लोगे तो ज्यादा नॉइज फॉर्म होगा, तो वो नॉइज रिडक्शन के लिए और भी बड़ा सेटअप चाहिए। और इनफैक्ट while taking ECG there are number of artifacts that, I mean in communication language it is called noise, but in biomedical case it is called artifacts. So the number of artifacts come inside the human body, ठीक है? जैसे कि ये हार्ट पंप कर रहा है तो इसके साथ साथ तुम सांस भी ले रहे हो और इसके साथ साथ तुम्हारा मतलब ब्लड भी फ्लो हो रहा है। So there are number of artifacts, the number of noise generative activities occurring in the heart. So to reduce this, the optimum number of leads have been taken as 3. Okay, and it was by research by William Eindhoven.
ओके सर। सर इसमें जो हार्ट है सर वो इसका सेंट्रॉइड है सर?
राइट, एकदम। जैसे कि इस फिगर में हम लोग देखेंगे, ये जो नेक्स्ट फिगर है इसमें देखेंगे दिस इज द सेंट्रॉइड, क्योंकि तुम जब ड्रॉ करोगे, जब ये आइंदोवेन ट्रायंगल तुम्हें ड्रॉ करना पड़ेगा, अगर राइट शॉर्ट नोट्स ऑन आइंदोवेन ट्रायंगल और हाउ आइंदोवेन फ्रॉम हाउ ट्रायंगल से तुम लोगों को कैसे ईसीजी का वोल्टेज मिल सकता है, ये सब अगर तुम लोगों को पूछा जाता है तो यू शुड हैव टू ड्रॉ इट। ड्राइंग तुम्हें तो सेंट्रोइड में ही ये मिलेगा।
Okay,
नाउ
sir.
एनी अदर क्वेश्चंस? Okay, no questions, so we will forward. Participants, you should have gave the attendance. Probably most of you have been, total I am seeing 30 participants are there. So please keep in mind that if you forget to give attendance in the chat box, your attendance will not be considered. Please keep in mind. So carefully, you should give the attendance in the chat box. Okay. Now, as it was told that the lead one, you can see the direction of the lead. You can see that from A to B, this is the lead 2. Sorry, this will be lead 1. This is my mistake. This is lead 1, VAB. Okay, and VCA, that is lead 3, and this is lead 2. This is a mistake. All are lead 2. So please, whenever I will share the PPT in the Google Classroom, I will correct it. This will be lead 1 as it was seen in the VAB. Okay, now V2, that is the voltage of potential of lead 2, that is VCB. Okay, this portion you can see VCB means from C to B, the arrow is given like this. Okay, and VCA, that is arrow is given like from C to A. So you should have remember this. Okay, so from this the centroid, or in the centroid, this is the heart. From heart you can see we are creating some perpendiculars to the perpendicular lines on the leads. Okay, now suppose this heart makes the angle of alpha with the parallel of the lead 2. So we can say this makes this V vector, creates an alpha angle with the lead 2. Is it so? Because this lead 2 and this line is parallel. Okay, we can apparently say that, not technically, this is apparently said that for assumption it was taken, because as the heart is there, we can clearly take a parallel of lead 2 and take an angle of alpha. You can see
लीड 1 होगा
huh?
सर, वो
सर
लीड
लीड
1
में
होगा
थोड़ा
ना,
कंफ्यूजन हो रहा सर।
लीड 1 होगा वो।
अच्छा, एक मिनट, just a minute, let me correct it first.
हाँ तो प्रीवियस फिगर से सर, प्रीवियस फिगर्स।
Now it is clear.
यस सर। सर इसमें आप जो वेक्टर समझाए सर, वो समझ में नहीं आया।
कौन सा
वेक्टर सर, वेक्टर बी जो इसमें डाले हैं सर, अल्फा एंगल जो है सर, वो
देखो, हाँ बता रहे देखो, ये लीड प्लेस किया गया, हम लोग प्रीवियस फिगर में आए हैं, ये लीड प्लेस किया गया। अब ये जो हार्ट का फंक्शन है, सपोज दिस हार्ट इज पंपिंग द ब्लड इन एन एंगल ऑफ अल्फा, दैट मींस जो हार्ट का
सर
जो
यहाँ
पोजीशन
पे,
है,
सर यहाँ पे लीड 2 एंड लीड 3 का पोजीशन तो अलग अलग है सर।
नहीं, यहाँ पे लीड 2 लीड 3 का पोजीशन अलग अलग नहीं है, क्योंकि इसको जस्ट मिरर किया गया इसमें। देखो, द राइट पार्ट इज इन योर लेफ्ट साइड, ओके, हियर द राइट पार्ट इन योर राइट साइड, जस्ट मिरर किया गया इस फोटो को।
ओके सर, ओके।
ठीक है, तो मतलब तुम लोग को समझ में थोड़ा दिक्कत होगा क्योंकि ये तो फोटो है, ये दिस वाज डाउनलोडेड फ्रॉम इंटरनेट सोर्स, तो इसमें हम तो कुछ चेंज नहीं कर सकते. To better understand you, I have drawn this diagram. Okay, so whatever where we are. Now the lead 1, lead 2, lead 3 concept are clear.
yes sir.
Yes, sir.
Okay. Now we are coming to the mathematical part. Now you can see this lead 2, the voltage of lead 2 is decided by minus V cos 120 minus alpha. Okay, and this value has been put it up. Similarly, voltage of lead 3 and voltage of lead 1 is connected. So in the Eindhoven's law, we have seen that voltage of lead 3 and voltage of lead 1 will act as the voltage of lead 2. Okay, so here it comes. Now this V1, the voltage of lead 1 and voltage of lead 2 and voltage of lead 3 is denoted by the Qi plus Ri plus Si. Now what is the function? I mean, what is the notation? That these Qi, Ri and Si are the peak values of Q, R and S waves in lead I. Lead I means I equals to 1, 2 and 3, nothing else. Okay, so these are the some mathematical notations which where these are nothing, no derivations are there. These are some notations, mathematical notations of electrocardiogram. I can see whatever it was discussed in the earlier stage, that there should be some time intervals between the PQ, QR, RS, ST. Okay, there must be some interval. So from P to Q, we can clearly see the image 0.16 second. These are some notations. These are the typical time intervals. Now, these time intervals have been taken from the physically fit human body. Okay. Now, suppose today I am not feeling well. I went to the diagnostic center and said that I need to check up my health condition, and it was seen that this PR interval has been changed to 0.14 second. Okay, and this ST segment or QT interval, better say QT interval, it comes like 0.40 seconds. So the doctor or the diagnostic, I mean whoever performing the diagnostic test, the doctor will say after seeing the report, your report is not normal. Okay, because he knows the standard value. He has the knowledge of these time intervals. If the record shows some other intervals, then he will depict like you are not well, your heart functions are not well, you need to undergo some treatments, firstly by giving some medicines, then if it is not solved, then surgery and so on. Okay, is it clear now how a person can be diagnosed as not healthy from this PQRST curve or the electrocardiograph?
Yes, sir.
Sir, is this given
Yeah.
time interval is standard for every PA?
Yeah, every healthy person should have the this kind of PQRST curve interval, just like the human blood pressure. तुम लोग तो जानते ही हो कि ये human blood pressure 80 और 120 ये नॉर्मल है. ओके,
80 by 120, yes sir.
हाँ ये नॉर्मल है. ये भी हम लोग बाद में डिस्कस करेंगे प्रोबेबली इन द नेक्स्ट वीक. तुम लोग का ब्लड प्रेशर जब बढ़ेंगे तो ये अगर चेंज होता है तो क्या बोलते हैं, हर घर में अभी हाई ब्लड प्रेशर और लो ब्लड प्रेशर के पेशेंट्स हैं, तो हम लोग क्या बोलते हैं कि नॉर्मल प्रेशर या 80 120 जब भी डेविएट होता है तब वो उसका हाई प्रेशर हो जाता है, बढ़ जाता है तो, और नीचे आ जाता है तो लो प्रेशर हो जाता है. जस्ट लाइक दिस PQRST curve, this is the standard. So 5% plus minus can be considered, because हम लोग जब भी जाते हैं उस किसी भी जगह पे गाड़ी से जाते हैं, पैदल चल के जाते हैं, तो there are some physical activities so that some variation in the PQRST, some changes will be there. Okay. So we are running out of time. If you are having any question, we can arrange for an interactive session tomorrow. If you want this, so if you want this, please post me in the group. So I'll arrange the interactive session for today's, this week. So Shruti, have a question you may ask through Google Classroom, because we are running out of time. For 5 seconds, this session will be ended. Okay?
Yes, sir.
Okay, thank you.
Thank you, sir.
Acha, Shruti, you may ask your question. Till now, this was not cut.
No,
Please
sir,
ask
I
your
was
question.
asking you to